Hello students, I am Dr. Charukha Mesra. Today we are going to complete the next topic, synthetic petrol. What is the meaning of synthetic petrol? Various gases, saturated, unsaturated hydrocarbons are produced by fractional distillation and the cracking, which can be used to get the suitable fuel for the internal combustion engine. For this, following two methods are adopted to increase the production of gasoline. In last class, we discussed the various methods by which we can meet the demand of gasoline or petrol, in which we studied about cracking. Now the next topic, that is a synthetic petrol, which we are going to complete today. Synthetic petrol, synthetic petrol can be prepared by the two methods. First, that is a Fischer method, and another is the Burgess method. According to Fischer-Tropsch method, first we are going to complete this Fischer-Tropsch method. Fischer-Tropsch method is also called catalytic cracking of water gas to get straight chain alkane and alkenes. What will do? The red hot hard coke. When steam is passes to the red hot hard coke, a water gas is prepared. At the high temperature, water gas is prepared. This is the construction, this is the apparatus by which we will prepare the gasoline. Here the water gas is passes through the excess of in the presence of excess of hydrogen. These are the purification chambers, compressor, converter or catalytic chamber. This is the condenser, and this is the fractional distillation column. First, the water gas is passes and the excess of when water gas is passes and the excess of hydrogen. First chamber, which is the purification chamber, contain Fe2O3, which removes the inorganic sulfur. In the second chamber, Fe2O3 plus Ne2CO3 is present, which remove the organic sulfur which is present in this water gas. After removal of this sulfur, inorganic and organic sulfur, this gas is compressed by the compressor at 5 to 25 atm pressure. After compressing, it is passes to the converter, or you can say catalytic chamber, where the temperature 200 to 250 degrees centigrade is maintained. Here we are using a catalyst which is 100 part of cobalt, 5 part of thoria, 8 part of magnesia, and 200 part of Kesselgar. This is the combination of catalyst which we are using here. After passing this catalytic converter or catalytic chamber, the water gas is converted into straight chain alkane and alkene. Here the reaction, this CO plus H2 combined together and forms alkene. It is an exothermic reaction. Heat is liberated here. If the excess of hydrogen is present, this carbon monoxide again react with excess of hydrogen and produces alkane. That means we will get, after catalytic converter, we will get the combination mixture of alkane and alkene, straight chain alkane and alkene. This gases is passes through the condenser, where they cool down, and after they are passing to the fractionating column, they are collected in the different fractions. The gasoline or petrol which is formed is collected from the top of the fractionating column, and the heavy oil which is produced is further cracked and produce the further more gasoline. First method, that is the Fischer-Tropsch method, which is also called the catalytic reduction of the water gas to get the straight chain alkane and alkene. We completed. Now we are going to the second method, that is the Bergius method. In Bergius method, coal is converted into the liquid or gaseous fuel by hydrogenation. That's why it is also called hydrogenation of coal in the presence of tin and nickel oleate. This is the apparatus where we are doing the Bergius process. Here, first in this chamber, paste of powdered coal and catalyst is powdered coal, which is the low grade coal or the bituminous coal is used here, which is spaced with the heavy oil and here the hydrogenation is occur in the presence of catalyst tin and nickel oleate. When this paste is passes through the converter, this is the converter at the temperature 450 degrees centigrade and the pressure 200 to 250 degrees atm pressure. Here the reaction is carried out about 1.5 hours after in the converter. The reaction in this reaction produces some gases, alkane and alkene gases, which is passes through the condenser. After passing through the condenser, we will get a mixture similar to the crude oil, which is further passes to the fractionating column, in which some uncondensed gases are collected from the top of the tower, and there are three main fractions are produced. First is the gasoline, which is a petrol like substance which we are using as a petrol, and the second fraction we are getting the middle oil after further hydrogenation converted into the gasoline to complete the more demand to produce a more gasoline. The third fraction is the heavy oil, which is further used to make the paste with the powdered coal. This is the complete process of Burgess method. In this process, we will get the 60% coal charge converted into the gasoline. Thank you.